Thank you very much, Professor Askari, for this wonderful presentation and great work, huge effort, and great data that I think there will be many discussions after the session and also during the Q&A part. In order to save time for the Q&A, I would like just directly to move to the next speaker, Professor Dr. Hesham Bekhit. Dr. Hesham, Professor of Water Resources at Cairo University. He is a consultant to the Ministry of Water Resources and Irrigation and the Nile water sector. He is currently the coordinator of the Water Engineering and the Environment Bachelor Program, and this is a unique bachelor program that graduates water and the environment and experts to the market. Thank you for all the people who worked to offer this program, and also to Cairo University and Ministry of Higher Education for supporting such programs. He is also an executive coordinator for the Shared Water Resources Diploma of Cairo University, a one-year diploma specialized in shared water resources management, hosting candidate from Ministries of Water Resources or Ministry of Irrigation from the Nile Basin. And I also congratulate him for working together with the Nile Basin countries. Professor Hesham Bekhit, you have the floor.
Thank you very much, Dr. Hani, for the introduction. Ladies and gentlemen, Your Excellency, the ministers, allow me today to walk you through a little bit different topic. We heard from my colleague, Dr. Hesham, very nice presentation about the use of the satellite images and how you can import information and do some modeling activity on that and have informed information in a certain area. So today I'm a little bit continue on the efforts. Instead of having the satellite image, if we need to understand more the process and the information in hand. So my topic today, I'm a little bit talking about the role of modeling and simulation in decision-making for water resources. So a little bit of introduction. If we look to the water resources, either you are doing planning, designing, managing, different protection, impact assessment, alternative developments, you need to do some kind of decision-making. And this decision-making, in order to be in a good direction, it needs a lot of support. And water resource system modeling is the powerful tool that can support this evidence-based decision-making. So today we'll try to show to you how we are doing in Cairo University, the modeling to assist the Ministry of Water Resources and the different other ministries in different sectors in trying to have what we call the evidence-based decision-making process. So the approaches that we are following in the modeling, we are following different criteria. We started from several input data. We collect all the relevant data that are contributing to the problem of interest, the geology, the topography, the hydrology, the geochemistry, meteorology, soil, name it. And we assess the data and see where is the gap, and then conduct some field work to close the gaps or have better understanding. And we do convert all this in type of layer GIS techniques, either the DEM, the delineation, the different criteria. We put all this in different layer of GIS, and then we conduct the analysis at the last stage. So this is kind of the approach that we are following in the modeling. For the scope, our scope is depending on the situation in hand. So in some cases, we are trying to modeling the simple situation of homogeneous cases. That's depending on the situation. Some cases we have heterogeneous cases, either from heterogeneity or from geochemical heterogeneity. So we are, depending on the case, we are designing the modeling appropriate to the case in hand. So this is the one in the top, a very simple situation, and the more heterogeneous either for the geochemical or the physical heterogeneity. And then, depending on the condition, in some cases, we have to work from regional scale to local scale. In a lot of the challenges that we faced during the projects, in some cases, the data that you have are in the larger scale, and the area of interest are in the smaller scale. And the smaller scale do not have the boundary conditions sufficient to model this one. So we develop our frame to work from regional scale to local scale, where we have some data at the regional level. From these data, we develop different conceptual models in the regional scale, and from these conceptual models, the different conceptual models, we do generate different alternative, like different simulation. Each conceptual model have different simulation, and then we do combine all these together to convert from the regional scale to the local scale. So we are combining all these type of activities together, and allow me today to show you one of the examples that we are working with the Ministry of Water Resources for the assessment of some of groundwater projects under the scope of the Ministry of Water Resources. So to conduct the groundwater model, this is the protocol that we are following. We start with the purposes, and we build the conceptual model for the groundwater model, and then we do the numerical modeling, and then we do the calibration using the field data. After that, we do a validation process to ensure that our modeling is performing well, and then we start doing the sensitivity analysis and doing the alternative assessment. After that, there is a very important point that you have to follow. After you do your modeling and you do the initial condition and then start implementing the solution, you have to continue monitor the performance of the aquifer and do what we call post-auditing to make sure that your model is performing in the right direction. This may necessitate that to reconsider your conceptual model again if the data that collected during the monitoring showed different behavior from the model prediction. So the modeling is kind of dynamic process. So we continue in this cycling of modeling to ensure that we are doing the model in the way that's help the decision maker for better decisioning or taking the decision that serve the water surfaces. So as an example, I'll share with you one of the models that we conducted for the Ministry of Water Resources in the area of El Moghra. So we start from the conceptualization, and this conceptualization for the geological formation. We collected all the bore logs data. We start building three-dimensional geological model, and this geological model converted into a different cross-section that feed into the groundwater model. And then we start to distinguish between the different layers and decided how to deal with these different layers in modeling approach. Then we rely on our GIS database. That's very important. To do a good modeling, you have to have a good data collection. And one of the achievements that have been conducted during the Ministry of Water Resources is the collecting all the data of the wells, all the data of water quality, of the geological formation, and bring them all together in one digital GIS database. So we start, depending on the area of concern, you extracted the information, either the water level, the water salinity, the depth to water, etc. The different GIS layers, you use them and integrate them in our model. And also one of the very important issue, that's the water quality. So in the ministry and during the modeling, we not only looking for the quantity of the water, but also we are looking for the quality of the water. In order to have sustainable development, you have to look on the both edges of the water quality. Then we do building the numerical conceptual model, and here are the second process of the calibration. We start to see the real data and how our model performing and how the goodness of the fit, and trying to make sure that our model is very close to what we are achieving from real data. After that, we look for the development alternatives. This is the case that we conducted, and start to do a comparison between alternatives. So we provide the tools to compare how the different alternative performs in different of drawdown, in terms of water levels, in terms of water quality. So this kind of tools help the decision making. I will do this, I will do that. In terms of this decision, it will not only look at the water resource, but as you know, water resources are cross-cutting issue. So it starts to do some economical analysis, social analysis, water analysis, water quality analysis. So we combined all this together in decision support tool that's provide all the different aspects of the alternative under consideration. So we start extracting from the model the result of the drawdown, the results of the forecast for the future, how the situation will be, and among the issue is what is the effect on the existing development. We don't need to shoot ourselves in foot. I mean, you need to do the new development. You have to ensure that the new development does not affect your existing development. And also, as I said before, it is not only about the water quality, the water quantity. In some areas, as the area I just presented here, we found that there are some water quality less than the top layer, the bottom layer having water quality less than the top layer. So while you are doing pumping to irrigate from the top layer, there will be a change in the salinity from the lower layer and the up layer. This causes what we call it the up cone effect. So there will be a migration of salt from the lower layer to the upper layer. This migration, this increase in salinity is increasing with the rate of abstraction. The more you abstract, the more you're enhancing the solute upconing effect. So what is the critical level? How I can assure that I'm not affecting my development? How can I assure that the new development should be sustainable? That I'm not affecting the sustainable. What is the critical limits? How we can stop? So we do the salt analysis as well. It's not only the water quality. We see how the salinity changing in the different layer with the timing, as you can see here, and we compare, as you can see here, the graph, the effect of upper cooning. That's the salt as migrating. So we do different alternative and compare between them and see, to ensure that the development can be sustainable. The development will be absolute after coming year. So we combine all this together and we present them in different layers with different quality. Then the matters goes to the decision maker. He have a layer for salinity, he have the layer for sustainability, he have the layer for effect on existing layer, he have a layer of economic analysis, he have a layer of socio aspects, and he start to put the weights and take the decision, informed decision based on the output of this modeling effect. So in conclusion, as the modeling and the way that the model is performing is fundamental component in the current practice of water system. However, in our opinion, the most important aspect of modeling today is the communication. We have both to understand the model assumption, the model limitation, and what the model do and what the model cannot do. And we should not overemphasize the impacts of the model. Here I need to recall the quote of Dr. George, which is one of the professors for modeling. He says, all models are wrong. However, there are some good models. but all models are wrong. The models are abstract of the reality, so we have to put these limitations together, and we have to communicate this with the models. However, this is the only tool that could lead to informed decision making. At the end, I would like to acknowledge my colleague. It's part of whole team, just with different years, ages, from professors, associate professors, and a lot of engineers. Thank you very much for your understanding.
Yeah.